Okay, this is just a sampling of questions from the 1.3 homework questions in AP Calculus AB. So if I put a 0 in, it gives me 0 over 0. Radical 5 minus radical 5 is 0 over 0. I can't factor cancel. There's no common denominator because you don't have a fraction and a fraction. I can't do direct substitution because I just tried it. That only leaves one thing, and that would be rationalizing. The conjugate of A minus B is going to be A plus B. When you multiply these, the result will be A squared minus B squared. Now, what is A? A is the radical x plus 5 plus B, the radical 5. So instead of radical minus the radical, it's the radical plus the radical. Now, if this is A, let me go back. If this is A, what's A squared going to be? X plus 5. The radical would go away. Now, if this is B, I always use parentheses even though you don't need it for this one, but for subtraction, it's good practices. If this is B, what's B squared? 5. On bottom or the denominator, you have a bunch of stuff. X plus 5, not H. X plus 5 plus radical 5. If you simplify the top, I think 5 minus 5 adds to 0. So you have this, where the x's could cancel. Now I have what's left is 1 over radical x plus 5 plus radical 5. Remember that x is approaching a 0, so if I replace that x with a 0, if I replace the x with a 0, I end up with 1 over radical 5 plus another radical 5, which is 1 over 2 radical 5. One radical plus another is 2 of them. Now, in calculus, you're allowed to leave the radical in the denominator, so that's the answer I would expect. If you look at the answer in the book, I think they rationalize the denominator, and they get radical 5 over 10. These are the same thing. I would accept either answer. Now remember, on a multiple choice test like the advanced placement test, you're not going to have 2 correct answers, so you're going to have to be able to manipulate one answer to make it look like another. So these are equivalent. On to the next problem. This is number 61. I cannot do direct substitution. If you put in a 0, you get 1/3 minus 1/3, which ends up with a 0 over 0. There's no radicals. I can't rationalize. I can't factor cancel, but there are fractions and fractions. To get a common denominator, you could just multiply the 2 denominators. So I'm going to multiply those 2 to get my denominator. I'll probably do this one time, not too many, because you really need to know that multiplication and division are inverse functions. So I'm going to do this once. I'll be very careful and meticulous when I write it out. And this is times 3, right? So I'm going to even write it differently. I'm going to write it 3 times 3 plus x over 1. And then this over itself. So this really is still a fancy form of 1. I haven't changed anything. It's just that now when I multiply, guys, when I multiply here and I do numerator times numerator, what do I get? You get 3 times 3 plus x. So I'll write that out. 3 times 3 plus x. How about when you do denominator times denominator? You get what? 3 plus x. In general, I had just said before the 3 plus x's cancel, leaving you 3. And that's exactly what's happening here, right? Now, what happens when let me go back a little bit so I can get rid of those. Okay, you had this over what? 3 plus x. Now, what happens when I multiply this times this? What's top times top? Numerator times numerator gives me 3 times 3 plus x. So I have 3 times 3 plus x. Now what happens when I multiply denominator times denominator? You get a 3. On bottom, you have x3 and 3 times 3 plus x. Now what happens? Can these cancel? Leaving me 3. Always use parentheses when you subtract. Could these cancel, leaving me 3 plus x? Many times I will skip that intermediate step because you need to know that division and multiplication are opposite or inverse functions. Cleaning this up, 3 minus 3 is 0. I think the only thing on top is negative x. And on bottom, you should have all of this. At which point I think the x's could cancel, leaving me negative 1 over 3 times 3 plus x. Remembering that you're replacing the x because x is now approaching a 0. So I'm going to put in a 0 for the x. So we'll put a 0 in. And you should have negative 1 over 3 times 3. So you should have negative 1/9 for the result. Okay, let's see if we can find some other ones. Do you know how to square x plus h? Anytime you have a binomial squared, like x plus h, the best way is to square the first, square the last, multiply those xh, and then double it. So this is going to become x squared plus 2xh plus h squared. When I distribute the negative 2, you get negative 2 minus 2h plus 1. How about if you distribute this negative? What do you get? It changes all your signs. Negative x squared, positive 2x, and a negative 1, I believe. Any questions on that? Now, if you do this properly, this whole last thing should subtract off. So, what's x squared and a negative x squared? 0. Negative 2x, positive 2x adds to 0. 1 and negative 1 adds to 0. That leaves me with 2xh plus h squared minus 2h, the whole thing over h. The limit as h approaches 0. I had been dividing them all by h, but somebody pointed out last period that, as somebody in here said, that might be a little bit too easy to do it that way. So let's do it the proper way. Let's factor an h out and cancel or divide them out. Now I have the limit as h approaches 0. So I'm going to take this, 2x plus h minus 2, replace the h with a 0, and my answer will be 2x minus 2. Okay, this had a binomial squared. One of them, I think 66, actually has a binomial cubed. It's not that hard. It's what? X to the third plus 3 x squared h plus 3xh squared plus h to the third. It's really not that bad if you understand Pascal's triangle and you realize that the coefficients are going to be 1, 3, 3, 1. So I usually save the cube ones for more like retakes and makeups, so I don't think you'll see the binomial cubed on your regular quiz. How about over here? To do these, you needed to know some, what do they call, special limits. There was two of significant importance. One of them was sine of x over x as x approaches 0. Sine x over x as x approaches 0 is 1. And the limit of 1 minus cosine x over x as x approaches 0 equals 0. If you can accept these two special limits, it'll make these much easier, I think. So, what I'm going to do is I'm just going to make these match those limits. So I have sine of x. On bottom, I have x squared, which could be called x times x. Do these match both of these limits now? I hope they do. So sine x over x is 1 times 1 minus cosine of x over x as x approaches 0 is 0. So 1 times 0 gives me my answer. Okay, I think I'm going to use these right here. I shouldn't cross them out. These right here, I will be using quite a few of these next problems. So what do we have on this one? Could sine squared be called sine of x times sine of x? Could x be x times 1? So I have this, of which I know the limit, and I have it times this, which I think I could do direct substitution. So I know this limit is a 1. If I put in a 0 here, what is the sine of 0? 0, and 1 times 0 makes my answer 0. Okay, 73, on to 77. If you look at a unit circle, guys, and I make my unit circle, I notice that I'm plugging in pi over 2. Pi over 2 is at the top here. The coordinates at that point are 0, 1. It's always alphabetical, cosine, sine. So what do we know? I know the cosine of pi over 2 is 0, and I know the sine of pi over 2 is 1. The reason I ask that is if I do direct substitution, I need the cosine of pi over 2. What is the cosine of pi over 2? 0. Cotangent is cosine over sine. And if cosine of pi over 2 is 0, what would you have on the bottom? 0. So basically you have an indeterminate form. It is 0 over 0. Because it is 0 over 0, I have to be able to deal with it in some manner, so I'm going to make a little room. I suggest breaking everything up into sines and cosines. Cosine obviously is just cosine. Cotangent is cosine over sine. So I have cosine, and how do I divide by this fraction? You multiply by its reciprocal, which would allow the cosines to cancel, leaving me just the sine of x. Remember, you're doing the limit as x approaches pi over 2, so I want to plug in for x the pi over 2. What is the sine of pi over 2? Apparently it is 1, and that should be your result. So ideally, you should know your trig identities, or at least the basic ones. Yeah, I think the trig is very important. I can tell you what I'm doing with my pre-calculus. I just gave him this problem yesterday. Sine of pi over 2 minus theta times cotangent of pi over 2 minus theta. What we're doing in their class is we're doing the cofunction identities. You should have done this last year if you're with me. Sine, when you do that, it turns it into its cofunction, cosine. Cotangent, when you have 90 degrees or pi over 2 minus theta, turns it into tangent. It's cofunction. And what is tangent? It is sine over cosine. Those could cancel. And this would just simplify to sine. So I don't know if you guys remember all your trig from pre-calc. I kind of assume you don't, but some of it will come back over time, I hope. Okay, on from 77, 79. 79 and variations of it tend to cause problems. If I put in a 0, e to the 0 is 1, 1 minus 1. E to the 0 is 1, 1 minus 1. So anyway, you end up with 0 over 0 again in indeterminate form. We have to deal with it somehow. I might do this, multiply by a fancy form of 1. When I multiply e to the x times 1, it becomes e to the x. When I multiply here, you add exponents. Do you agree? Negative x plus x is 0. And what is e to the 0? 1. Could that now cancel with the e to the x minus 1 in the denominator? So we have the limit as x approaches 0. Those will cancel. So I have 1 over e to the x, 1 over e to the, what is x approaching? 0. So you end up with 1 over 1, or an answer of 1. Okay, from 79, we're going to move to 81. I know that they gave us this limit. The limit of sine of x over x as x approaches 0 equals 1. The main thing is these have to be the same. The angle and the denominator have to be the same for this to occur. So I kind of agree with somebody last period. Why water it down? Why not just say 2 times what makes it 3? And if I was to do that, I'll say it again. 2 times what is 3? Well, it would be 3 halves, right? And 3 halves over 3 halves would make it into a 1. So now I have this over 3t, which makes it 3 halves times 1, or an answer of 3 halves. Normally, I teach it this way. Sine of 3t over 2t, and t is approaching 0. Pull the 1/2 out. Sine of 3t over t. You got to make that a 3, so you got to do this. And so that's a 3 halves. Sine of 3t over 3t. That limit is 1, giving me a result of 3 halves.